Welcome to Project 12, and in this project we're going to be working with strike and dip of a plane or a surface. Now, first thing we got to do is we got to understand the difference between an azimuth and a quadrant. And these are just directions, and when we look at azimuth and quadrant, it's always on the horizontal plane, which is typically the top view, or if it's in architecture, it's a plan view. So just remember that. And the difference between an azimuth and a quadrant, of course, is azimuth starts at 0 north, goes clockwise around to 360, and then a quadrant is split up, just like it says, a quadrant split up 4 times. You got 4 sections that are 90 degrees apiece. You got northeast, southeast, southwest, and northwest, and they always go from the poles 0 to 90 north, east, 0 to 90 southeast, and so on. So that's how all that works. And we're going to flip through here, and this little website that I'm using is from Georgia Tech University, and a really good little PowerPoint here, and you can access that by going to this link you see above. So I'd recommend it. It's a good little tutorial to show you how to do some of this. But I want to slide on through, and we're going to get to what's the difference between a strike and a dip of a plane or surface. Now, a strike would be on the horizontal plane. It's always a line on the horizontal plane. And looking at it right here, it's going east to west, the direction is. And that was my strike. And my dip is the angle coming off of it at a perfect 90 degrees. Okay, let's make a little bit more sense of this. This does a little bit better in this little illustration. Up here would be my strike, and this thing is traveling in a northeast direction. We'll say we're running up through here. This is our strike line, and the dip comes off that horizontal plane, and it's just an angle from 0 to 90, and it gets this it gets the slope of this, and they call it a dip. So if you ever someone asks you what is the strike and dip of a line, first you got to give them your strike in either an azimuth or in a bearing, and then you give them your dip angle from the horizontal plane down to that plane of projection, down here to this plane, and it'll also be in either an azimuth or not an azimuth, but it'll be in a direction, and we'll talk more about that. But always look at this. This is the strike and the dip coming over. Now, if we're coming up like this in this direction, this would be a northeast strike. Well, this has to be 90 degrees, the dip that comes off of it. So if you look at it, this dip is coming over, and it would be going in a southeast direction. We'll make more sense of that here in just a moment as well. Now, this is how you record a strike and a dip. Again, the first thing is a strike, and see south 85 degrees east, and then you put in your dip, which is 23 degrees southwest. I want to show you what they're talking about. It's easy to understand this one on the horizontal plane. That's just our regular bearing. But how do you get this southwest for the dip? And we're going to get into that a little bit more. This down here is just wrote in an azimuth form. So I'm going to open up AutoCAD and have a little example here. Now, this example is got some contour lines on it, and it's a civil type of drawing. And always remember, when you're finding the dip of a line, it's always going downhill. It's never going uphill. So a dip always goes downhill, just to make that clear. But first, let's look at the first thing we do. Let's find the strike. And this red line is representing what I want you to figure out. In a strike, basically, If this is due north right here, this line is due north, you just got to figure out what the angle is, degrees, minutes, and seconds. And this is going in a northeast direction, so the strike angle is north 50 degrees, 40 minutes, and 49 seconds east. Now, the dip comes off of this. Do y'all see this? The dip right here is this dip line, and it's coming down. We want to know what kind of angle that dip is. Now, this is a southeast dip. Remember we talked about the dip has direction? Well, if you look at this thing's going northeast, you're just using the north here. Which way is this line going? It is going in a southeast direction. That's all that means. So when we're finding dip, we have to put southeast on that dip. But let's go over here, and I've drawn a little profile shot of this. This is the 200-foot contour. There's 200 foot to that point right there, and it's going downhill to 190 foot. So only thing I did was my horizontal plane, I got a calculation here. I got a distance between these two right at this dip line where we was looking at that, and the dimension from this contour to this contour is 10 foot. I put the 10 foot on there, and of course from 200 to 190 was 10 foot when I subtracted those. The only thing I had to do after that was just take and go in here and do an angular dimension, and I found this was 45 degrees, which 10 foot and 10 foot would be a 45 degree angle. So that's my dip. And we look up here, and my dip angle is south 45 degrees 0 minutes 0 seconds west. So that's as basic as it gets. It's not too difficult. It's not hard to understand. But we can also find the strike and dip of a surface. Now, this is what we've been working on a lot, is these oblique planes. And this line right here, I want to know what the strike of this is. So that's really simple and easy. I'll go up here and grab my angular, and I'll go off this line that's straight up and down, and I'll get that dimension right for you. And just to save some time, I'll just pull up properties, and we'll set our text and everything here. We'll set that like to 1 foot. We could annotate that and set that up in annotative, but we'll do that. So the strike of this line going in this direction is 56 degrees 38 minutes 56 seconds, and that's going in a northeast direction. So basically that's your strike, and we could go ahead and we could write it up there, but I'm not too worried about that. And now I'm trying to find my dip, and my dip would be going in this direction, and I want to get right there and bring it down, and it's going to be perpendicular coming down through here, and that doesn't look perpendicular, so we'll go to parametric. We'll use a perpendicular tool here. There we go. And it has to be 90 degrees, remember, and that's what that perpendicular does for us. I'll go back and trim this off, make it look nice and neat. So again, I think I had that. I'm going to change that just real quick to green. So, and it's the direction of this one, according to this, is going downhill as well. So I want to find out exactly, and I'll go here and grab this, do a copy. So this right here is my dip direction going downhill, so I want to find out exactly what my dip is. Alright, so all I have to do is something we've done earlier, and I want to take and do an auxiliary view. You remember the revolution method That's what I want to do here. And basically, all we have to do on that is just take and move this line. I want to revolve this line around to where it's exactly flat. And I think that would be the best thing we could do here. So I want to take this, and I want to take this, and I want to rotate it about this axis right here. And to do so, I want to take into a mirror. I want to catch this point. If y'all remember, that's been a while since we've done this. Catch it right there. That's going to be my rotational line. And what I have to do is just grab everything. I'll grab all that, and I'll grab all this. And then I hit a rotate. Catch that point. And I want to go to right there. So now, undoubtedly I didn't catch that line to go with us. So delete that out. And I'll just put this line back in there so we'll understand what that is. And that's an extra line that we put in there, that mirror line, just so that we'll know exactly where that was at. And alright, so we've got that set up. This line is exactly horizontal. That's where we wanted it at. Now all we have to do is start, let's just do an offset of this line right here down. We're just going to do a quick offset and do like 10 foot. Put it right there, and then I just start, and I always like to extend my lines. I've always done that, just a habit. Bring that over. I'll extend that one over to this one. Now I'm just going to take and I want to bring my lines. I want to offset. This is going to be, I'll just go ahead and bring these lines on in. First bring them straight down, just like this. Bring that straight down just like that. Bring that straight down just like this. Okay. Now I want to take and I want to figure out exactly what this is, what the dimension is from here to here. Or actually, that'd be fine. We'll just go from the top here to this point. First we need the overall dimension. Do an alignment. That's rather small. We'll just zoom in there and do an offset. So we got 10 foot, 9.3872, enter. We'll come in here and go from that point to there. So this is the actual height of this part, where we took this and we rotated around to look at this thing straight on. Alright, from this point to this point, let's get a little measurement on it to get that little spot in there, and we'll do an offset 2 foot 6.6870 inches, enter, and we back out of it. We go from this point to this point. So we've got that little height in there, and that should be the only two dimensions we need for this. So at this point, all you have to do is just kind of start trimming everything up. But also, this thing is going to look like this. This line now would be gone. We'll do just a little bit of a trim. Oops. do some trim work. Clean some of this up. Uh-oh. I needed that. We'll do a little trim. We don't need this. This. We don't need this, or this, or this, or this, or this, or this. That looks a little better. So at this point, this is that auxiliary view, and as you can see, this plane now is completely turned around where we can see it. We rotated this over so now you can't see the true size of this auxiliary or this surface. However, we can take and make a right side view of this now, because this thing is looking right at us straight on. Okay, this is that cut. Whenever this thing folded up, this part, we got this thing squared up levelly. So now I can go to the right side and do a right side view. Let's bring this one straight on up. I don't need all of the drawing, I just need a little bit of it. Bring this one across. Bring that up at a 45 miter line. And you'll see what I'm doing here. I'm just going to catch this point right there and bring it down. I need to also bring a line over here and across. So at this point you're going to catch from there up to there. So at this point, this right here will be our dip, and I think we'll just take and trim it, make it look a little bit more realistic. So what we did was we took this, we revolved this around so we could do an auxiliary view to look at this thing straight on, and then we just turned it to the right side. We just pulled a right side view, and they call this a secondary auxiliary, just so that we could see. This was the primary auxiliary, this was the secondary, just so we could see that dip. And then of course, to find that dip, we just do an angular dimension, and we'll zoom in here, and that is 45 degrees 11 minutes and 22 seconds. So we're going to take that number and I'll put it right up here somewhere. I'll also go to properties. We'll make it a little larger so we can see it. And again, we look at this thing. This was northeast, so I want to grab some of this over here. Bring over to this side. Alright, now the strike angle on this line, if we go here and double click this, let's change it real quick. This one's 56. That's very similar, wouldn't they? 56, 38, 38, 56, degrees, and that one's going east. That's right. And then the dip angle, of course, if this one was northeast, this one was going to southeast, or southeast, and we undoubtedly hit west a few minutes ago on that one. That's my apologies on that one. Hit east, and we found out this thing was going, right here's our number, 45. Man, those two things are very, very close. 11, 22. So, of this line right here, of this little surface, the strike angle is north 56, 38, 56. The dip angle was going down at an angle of south 45 degrees 11 minutes and 22 seconds east. And of course over here on this is civil, this first one was right, but now this dip angle, again, it was southeast. I've got southwest, so I want to change that so there's no confusion.